Hello friend, today we will talk about integral equations. Okay, so first of all, what is an integral equation? Okay, an integral equation is an equation, okay, in which an unknown function appears under one or more integral sign. Okay, that is, an unknown function appears under integral sign. This is an integral equation. Okay, now the most general type of integral equation is of the form, and the form is gx yx equal to f of x plus lambda integration over a to b, sorry, not b, a to b, a to box kxt yt dt. Okay, in which is gx, fx and kxt, these are known function. Okay, these are known functions where the lower limit, this is fixed, that is constant, and the upper limit, this either a constant, that is fixed, or variable. Okay, the upper limit either fixed or variable. Okay, and this yx, this is an unknown function. Okay, this is unknown function, and this lambda, this is a parameter. This is a parameter. It may be real or complex. Okay, now our definition is unknown function appears under integral sign. Now this yt is unknown function, and this is under integral sign, so this is an integral equations. Okay, now there are two types of integral equations. First of all, freedom integral equation. Okay, and its form is similarly this f of x plus lambda integration over a to b kxt yt dt. Here you see that the upper limit is fixed, that is a constant. This is a freedom integral equation. Okay, now if this gx is 0, then we get a 0 equal to f of x plus lambda integration over a to b kxt yt dt. This is called freedom integral equation of first kind. Okay, freedom integral equation briefly written as this. Okay, now on the second is, if gx equal to 1, then we get yx equal to fx plus lambda integration over a to b kxt yt dt. Okay, this is called a freedom integral equation of second kind. Okay, now if gx equal to 1 and fx equal to 0, then you get yx equal to lambda integration over a to b kxt yt dt. This is called a homogeneous freedom integral equations. Okay, this is called homogeneous freedom integral equation. Okay, so a freedom integral equation of first kind, freedom integral equation of second kind, and these are freedom integral equations of second kind with homogeneous. This is second kind. Okay, now in the definitions, so integral equation is an equation in which unknown functions appears under one or more integral sign. Okay, now this kxt, you see that this kxt, this is called kernel. This is called kernel of the integral equation. This is very important. This kxt is called the kernel of the integral equation. This. Okay, now there are two types of integral equations. First of all, freedom integral equations where the upper limit is fixed, and the second is Volterra integral equation. Volterra integral equation, and its most general form is gx yx equal to f of x plus lambda integration over a to x kxt yt dt. You see that the upper limit, this is variable. Okay, when upper limit is fixed, then the integral equation is freedom integral equations, and when the upper limit is variable, then these are Volterra integral equations. Okay, now similarly, if gx equal to 0, then we get Volterra integral equation of first kind, similarly as previous. Okay, if gx equal to 1, we get Volterra integral equation of second kind, and when gx equal to 1 and fx equal to 0, so we get Volterra integral equation of second kind, and this is homogeneous. This is homogeneous Volterra integration of second kind. Okay, now you see that kxt, this is called kernel of the integral equation. Okay, this kxt is called the kernel of the integral equations. There are many types of kernels. We only discuss about separable kernel, second iterated kernel, and resolvent kernel. Okay, we only discuss about this kernel. Okay, and this is important, and this is also okay, and this is important for eigenvalue and eigenfunctions. We talk about this later. Okay, so first of all, separable kernel. A separable kernel is a sum of a finite number of terms, okay, where each term is a product of x and t only. That is, this is can be written as g I x h I t, I equal to 1 to n. This is finite, sum of a finite number of terms where each term is a product of function of x only and function of t only. That is, this can be written as g1x h1t, g2x h2t, and gnx hnt. So separable kernel is a sum of a finite number of terms where each term is a product of function of x only and a function of t only. Okay, and the next, iterated kernels. Okay, and then separable kernels. Now the iterated kernel let's talk about iterated kernels. It's very important. Okay, so first of all we consider freedom integral equation. Okay, of second kind, that is yx equal to f of x plus lambda integration over a to b k xt yt dt. Okay, so the iterated kernel knxt for n equal to 1 to dot are defined as defined as k1xt, this is nothing but kxt. Okay, k2xt, this is integration over a to b for freedom integral equations, a to b kxz and k1 zt dz. You see that z is another variable and integral over dz. Okay, the integration is taken for z, only z. Okay, so similarly we get knxt, this is nothing but integration over a to b kxz kn minus 1 zt dz. Okay, this is our iterated kernels for freedom integral equations, but it is different in Volterra integral equations. Now consider Volterra integral equation of second kind, that is yx equal to f of x plus lambda integration over a to b kxt yt dt. Okay, so sorry a to x. Okay, similarly the iterated kernel knxt n equal to 1 2 dot are defined below, where k1xt is always kxt, but this is interesting, k2 of xt, this is integration over not a to x. Okay, integration over t to x, this is very important, t to x from this to this. Okay, and kxz k1zt and dz, this is our main thing, integration over t to x, this is important. But in freedom integral equations the integration is taken a to b, that is this, but in Volterra integral equation this is not a to x, this is from t to x. Okay, so similarly knxt, this is integration over t to x kxz kn minus 1 zt dz. Next we talk about a resolvent kernel. Now resolvent kernel is, consider Volterra integral equation of second kind. You can consider Volterra integral equation of second kind, that is yx equal to fx plus lambda integration over a to b kxt yt dt. So this is freedom integral equation of second kind. Okay, and let kmxt be mth iterated kernels, okay, of the integral equations of these integral equations. Let r x t lambda be the resolvent kernel of this one. Then we can write r x t lambda is summation over lambda to the power m minus 1 km xt m equal to 1 to infinity is an infinite series. Okay, if this infinite series exists, then the solution of 1 is can be written as yx equal to fx plus lambda integration over a to b r x t lambda f of t dt, not yt. This fx can be written as f of t. Okay, this is our solution. This is very important. Our xt lambda is lambda to the power m minus 1 km xt m equal to 1 to infinity. This is an infinite series. Okay. Similarly for Volterra integral equations of second kind, that is yx equal to fx plus lambda integration over a to x kxt yt dt. Okay, similarly if km xt be the mth iterated kernels, okay, of this 2, if rxt lambda be the resolvent kernel of 2, then this can be written as similarly as above, lambda to the power m minus 1 km xt m equal to 1 to infinity. Okay, this is also an infinite series. If this infinite series exists, the solution is yx equal to f of x plus lambda integration over a to x r x t lambda. This fx can be written as f of t and dt. Okay, this is very very important. You can also see that. Consider a freedom integral equation of second kind. Okay, and kmxt be the mth iterated kernels, okay, of 1. If this be the resolvent kernel of 1, then rxt lambda is summation over lambda to the power m minus 1 km xt m equal to 1 to infinity. This is very important. This is an infinite series. If this exists, then the solution of 1 is this. You can see that fx can written as f of t. Okay, now I can discuss a very important theorem converting multiple integral into a single ordinary integral. This is very important. Okay, and this is nothing but if a to the power x a to x integration a to x a to x a to x integration is n times, okay, yt dt n. Okay, since the integration is n times, so dt is n times. This is can written as 1 by n minus 1 factorial integration over a to x minus t to the power n minus 1 yt dt. Okay, very important. Integration of a to x n times, then this is 1 by n minus 1 factorial integration over a to x minus t to the power n minus 1 yt dt. For example, if we take yt this, so this can be written as, so this is 1 by 2 factorial integration over a to x minus t square yt dt. This is very important, that is converting multiple integral into a single integral. Okay, and also a very good result, Leibniz rule of differentiation under integral sign. This is very important. Leibniz rule of differentiation under the integral sign. This is very important. So suppose कि xt and del f del x, that is integration over the first variable. Okay, in the first variable this is continuous. Okay, both are continuous functions of x and t. Okay, and suppose ax and bx both are continuous, and its first derivative is also continuous. Okay, then ddx of integration over ax to bx f of xt dt, you can see that the integration is over t but the differentiation is over x. It's very important. Okay, so this is nothing but integration over ax to bx del x f of xt dt, that is partial integration of f with respect to x plus f of x, put the value of bx in place of t, that is bx, and differentiating b with respect to x, so ddt of b of x. Okay, so b of x minus f of x, put the value of this ax and sorry ddx and ddx of ax. This is Leibniz rule of differentiation under integral sign. Okay, if ax and bx are constant, you can only do this, not this. Okay, because the differentiation of a constant is 0, so this term will be 0, this term will be 0, so you can only write this. Okay, if ax and bx is constant, then you can only write this term, not this. Okay, now the initial value problem, always convert it into a Volterra integral equation. It's very important. Okay, and a boundary value problem, always convert it into a freedom integral equations. Now What is an initial value problem? I can question when and ordinary differential equation is to be solved under conditions involving dependent variable and its derivative at the same value of the independent variable. Then the problem under this consideration is called an initial value problem. That is, when an ordinary differential equation is to be solved under conditions. What conditions? Dependent variable and its derivatives at same value of the independent variables. This is very important. That is, for example, y double dash plus y equal to 0 when y of 0 equal to 0 and y dash of 0 equal to 0. You can see that the dependent variable with respect to x equal to 0 and y dash with respect to 0 at the same point. Okay, when an ordinary differential equation is to be solved under conditions involving dependent variable and its derivative at the same value of the independent variables at the same value. When different value of the independent variables, then this is called a boundary value problem. When an ordinary differential equation is to be solved under conditions involving dependent variable and its derivatives at different values of the independent variable, then in the problem this is called boundary value problem. Okay, for example, y double dash plus y equal to 0 when y of 0 equal to 0 and y dash of 1 equal to 2. Okay, that's at different values. Or now consider y double dash plus y equal to x with y of 0 equal to 0 and y dash 0 y dash 1 equal to 0. This is boundary value problem. Okay, this is important. A boundary value problem always transform into a freedom integral equations. This is very important. An initial value problem always be converted into a Volterra integral equations. Initial to Volterra and boundary to freedom. Eigen values. This is the last topic. Eigen values of a homogeneous freedom integral equation, that is yx equal to lambda integration over a to b kxt yt dt. You can see that yx equal to 0 is always a solution. Okay, and this is called a null solution or zero solutions or trivial solution. Okay, of 1. Now what is eigenvalues? The what values are the eigenvalues? Now here this is important. The values of the parameter lambda, the values of the parameter lambda for which one has a non-zero solutions. The values of the parameter lambda for which one has a non-zero solutions, and these values of lambda are called eigenvalues of 1. And okay, that is the values of the parameter lambda for which this has a non-zero solution, and then these values are called eigenvalues. And the corresponding integral equation is an eigenfunction. Okay, that is suppose if phi x is continuous and phi x this is non-zero, okay, on AB, and if phi x equal to lambda 0 integration over a to b kxt phi t dt, then this is an eigen function corresponding to the eigenvalue lambda 0. Okay, this is obvious. Okay, in the next video I can discuss some problem of these topics. Okay, so please subscribe my channel and share with your friends.